Okay. Well, hello and welcome to another DevNation live stream. We're coming to you live from, in my case, Raleigh, North Carolina. I have with me right now a fellow named Dewan. And Dewan, tell us where you're from real quick.
I'm from Pickering, Ontario, which is a small town east of Toronto.
All right, he's up north, so it's kind of cold up. Is it kind of cold up there?
Well, today's raining, so we're still in single digit, but that's okay. I mean, for Canada, that is warm.
That is fantastic. And I'd have to say down south here where I'm at in North Carolina, looking out the window, it actually is pretty warm. It's pretty warm today. As I'm wearing shorts and t-shirt again, had to turn the air conditioner on. It's kind of crazy.
Nice. Well, I have my shirt on, especially for this recording.
Well, that's a good thing. We don't want you naked. You know, just to make that clear. But I see James here. So James is here, DJ Maddie's here, Alexander's here. Always good to see all you folks. James, good to see you here. See Sebastian out there too. That is fantastic. So today I'm standing in for Edson. Edson, who's often the host of our show on Thursdays now, could not make it. He had to go take care of some paperwork. But what we're going to be talking about is Tekton today. So I see you guys hanging out on Twitch, hanging out on the YouTube channel. I'll be posting you guys some links in a moment. But at this point, I want to turn it over to Dewan, who's going to tell us more about Kubernetes-native pipelines and automation and all that good stuff around the Tekton universe. Over to you, Dewan.
Perfect. Thanks so much, Burr. So before Tekton, Dewan, just to tell a bit about myself, I recently moved over from IBM into Red Hat, and I'm at IBM. I work as a dev advocate where I work on OpenShift, Tekton, DevOps, and I hope to do the same thing in Red Hat as well. So today's demo and today's presentation would focus beginner level Tekton. So I understand that some of you are probably expert at Tekton, and if you are, please feel free to answer the questions on my behalf. But yeah, for anyone else, we'll have the links for everything, for the demo, for all the other resources at the end of the slide as well. And one heads up is if you have any question, please feel free to ask anytime. You don't have to wait till the end of the presentation. If I'm sharing full screen, I might not be able to see the question, but Bar would be kind enough to interrupt me and then ask me those questions. All right, so if it's okay, I can start sharing my screen, waiting for your thumbs up.
Right, let's see it.
All right.
Oh, not yet. Got to make it through. Try that screen share one more time. There we go.
Okay, perfect. All right, so the introduction part is done. And in terms of agenda, we have 3 sections. One is the usual stuff, which is the theory, right? Like the boring stuff. The middle part is the demo. So we have a short and sweet demo on Tekton, but the last part is I'm most excited about, and that is the Q&A. So that is where you ask me tough questions and I'm unable to answer and direct you to my Twitter. Just joking. Feel free to ask questions, and the Q&A would be the most exciting part. So what is the issue here? Why we're even talking about Tekton, Kubernetes, CICD DevOps? Like, why are we even here? So if you look at the landscape, there are a lot of tools, and some of you might know these tools and you're using these tools, but from 10,000 feet, there are all these tools, and even devs are facing challenges on which particular tool to pick. And imagine if you're a developer, how much difficult it is for your clients who might not be as technically expert. So in order to tackle that problem, Tekton project started. So it span off from the Knative build project. And the goal was to be an open source framework for creating reusable CI/CD systems. So it runs on Kubernetes and it uses CRDs to extend Kubernetes. So for those of you who know Kubernetes, you know that out of the box, Kubernetes comes with resources like pods, deployments, and services. But CRDs, which is custom resource definitions, extends Kubernetes itself. So that's how Tekton is built. So it leverages existing Kubernetes resources, but it adds some extra layers to make Tekton what it is. I'll have some other diagrams that would show the different pieces of Tekton, and the demo would make it more clear. But from this one slide, if there is one thing that you wanted to take away, that would be reusable CI/CD system. So that is the key point to keep in mind. All right, so let's go over some of the Tekton core concepts. And if you don't have to read if the text is too small, so you don't have to read that, I'll explain how this picture is laid out. So there are a few main pieces of Tekton. The first one is a step. Now, step is not a new concept. It's a Kubernetes container spec. So you can think of spec that just runs an image and you can do something. Let's say as simple as you can echo a command. And multiple steps form a task. And these steps can run on a single Kubernetes node, and they run sequentially. Now, if you have multiple tasks, that form the pipeline, and there's no guarantee that these tasks would be running on the same Kubernetes node. They could be running in multiple Kubernetes nodes, and you can run this task either sequentially or parallelly or as a graph. One advantage would be, let's say for faster tasks like linting and unit testing could go first, and then more heavier tasks with more resources could be done at a later stage. The entire thing you see on my screen right now, that is pipeline. Now here I'd like to lay out two differences. So if you're coming from an object-oriented concept like Java, so in Java we have a concept of classes versus objects. So objects are the instances of the class, which is the blueprint. So the pipeline in itself, it doesn't do anything. This is just like the Java class, the blueprint. Pipeline run is the actual instance which executes the pipeline and does all the magical stuff. And we'll see that later in our demo. So Tekton by itself is an umbrella project. That means Tekton project on GitHub has multiple projects. And there's this pipelines project, which is the backbone of Tekton. There's triggers, which we're not going to focus on today, but that is related to webhook. And if you want automated triggering based out of any Git issue you have, dashboard, which is a nice UI where you can see all your Tekton resources and pipeline and the logs. CLI, which is the TKN, Tekton command line. You can do all those things using kubectl or OC if you're on OpenShift, but TKN adds a wrapper on top and makes some nice abstraction. And catalog. So remember I mentioned about the reusable CI/CD part, that is Tekton catalog. And we'll see during the demo how there are tons of resources that Tekton open source contributors have already created so that your CI/CD engineer can pick and choose the pieces they need for their CI/CD system and use it right away. And there is more. All right, so now the burning question, when to choose a Kubernetes-native CI/CD server, right? So I come from a background of consulting, and I was privileged enough to talk to a lot of our enterprise customers as well as a lot of startups. And from my experience, the question to ask first is, are you using Kubernetes before you actually have the discussion of Kubernetes native CI/CD server? That means, are your applications following the certain architectural pattern? Are your applications running on as containers with microservices framework? Because what Kubernetes allows you to scale your containerized applications. If you have lots of containers, Kubernetes takes care of the scheduling and scaling. So if you're not even there for container part, it's kind of difficult to talk about Kubernetes native CI/CD server. So that is the first question to ask. And if you're using Kubernetes already, you have multiple Kubernetes cluster. In the next slide, we'll see how that makes our life easier. So one thing to keep in mind, to answer Kubernetes CI/CD native or not, the question is Kubernetes or not. And I believe there are tons of resources, books, and talks out there which will convince you if Kubernetes is the right solution for your particular application or not. All right, so this is a table which kind of highlights the difference between a traditional CI/CD server and a Kubernetes native CI/CD server. And the first one is the obvious one, logging and monitoring. Who doesn't like logging? So if you have a traditional CI/CD server, I'm not going to name any particular traditional CI/CD server to be on the safe side. The logging and monitoring is an external agent. That means you have to log into some server, SSH to some server, and see the logs. Whereas in Kubernetes-native CI/CD server, let's say you're using Prometheus or Grafana, it's just reading a CRD. So it's all centralized logging and monitoring, which makes life a lot easier. Second thing is high availability. So oftentimes with traditional CI/CD server, high availability is not just possible, or maybe they have one documentation which is very hard to implement. But on Kubernetes-native CI/CD server like Tekton, it runs on Kubernetes. So if you have configured your cluster with HA, the platform guarantees high availability. The third one is self-healing. Now I understand that some traditional CI/CD servers often offer the retry logic, but that is not same as self-healing. So Kubernetes pod, if one pod goes down, depends on your replica set, there's another pod spinning up. And in engineering, one of the best solution to fix any problem is restarting, right? Just turn the switch on and off and on. So self-healing for Kubernetes comes by default. And last but not the least, most traditional CI/CD servers come from a pre-container era. So in order to run them using containers, it's a patch, it's like a plugin. But solutions like Tekton, they were born in the Kubernetes era. So they run containers on Kubernetes. So it's a much more smoother solution. All right. So enough talking, and I know a lot of you are fond of demos, just like me. So let me start the demo, and hopefully you can see it. All right, so I'm gonna pause the demo first and explain what's gonna happen. So what we have is we have a Java application on a public GitHub repository, and what we're trying to do is we're gonna use Tekton to do a build and push, and once that happens, we're going to have a message sent to Slack, and then we're going to have the application deployed on Kubernetes. So I'm going to mention throughout the demo what's happening. So the first thing is this is the repository. In this the repository link is added at the in the slide as well. So I'm checking my Kubernetes version. So here I'm checking the OC version. So it doesn't matter if it's OpenShift or Kubernetes. You could use either or. And I'm checking the TKN. So this shows me the Tekton version, which is the Tekton pipeline version, and the Tekton CLI and triggers version, which is not relevant, but the pipeline version and the Kubernetes version is important. All right, moving forward. So from that repo, which I just cloned, I see this is the files I have. And the first thing I'm going to specify is the Git resource. That means I have to specify where is my source code. And the source code is that Java directory. And once I do that, I have 3 tasks. The first task is a task build source. So here I'm reusing a task. So I didn't write that task. I'm taking this task from Tekton catalog, which I'll show right after the demo, all the other tasks we have. So this task fetches a repository, the list source. There are 2 steps here. One is the list source step, which you can see on your screen. And if it's too small, you can refer to the repository at the end as well. And the second one, the build step, that actually does the work of doing the build and push. The second task I have is task deploy. So this does a kubectl apply to deploy the application on the Kubernetes cluster. Now these 2 files I have on my local machine, so I can just do a kubectl OC apply or kubectl apply. The third file, which is a reusable task for Slack task, I don't have it in my local, so I'm gonna use a URL to apply that. All right, so I can do TKNTLS. So TKNTLS is short for Tekton Task LS, so which lists the task. And I'm showing here where, so this is the catalog, which you can see. So on Tekton catalog, I found a task that sends a message to Slack. So I don't need to write it from scratch. I can just reuse that particular task, that YAML. And I didn't have to change one single bit in this file, which is a fantastic thing. All right, so in order to install this task, I do one more kubectl apply, and hopefully once that's done, I'm going to have 3 tasks in total. All right, so do a TKNTLS. So I see I have 3 tasks, which is fantastic. The next part is I have to have my pipeline. Now, what this pipeline shows is, in this pipeline, I'm specifying the tasks that are part of this pipeline. So I'm saying that the first one is build image from source. This is the first task. And the second one is post to Slack on build and push. And it might be smaller font, but at the very bottom of this screen, you can see run after, which is a command. I'm mentioning that the second task has to run after the first task, because remember, this task could run either parallelly or sequentially. All right, so that is the pipeline file. So I have the 3 tasks and deploy application, and I'm specifying the parameters and resources. Now I do OC apply of this pipeline.yaml, and I have now the pipeline. So I can do a TKNTLS, which is short for show me the pipeline I have, and I'm connected to my OpenShift cluster as well. Now at this point, so this is not talk about Kubernetes versus OpenShift, so I'm not highlighting all the cool features OpenShift has to offer, but just get to show you this cool dashboard. Shows you your pipeline just like you can see from your command line. So I can see the pipeline was created, but nothing's happening now because this is just the blueprint. We don't have the object created yet, which is this pipeline. Now, the pipeline run is the actual meat. So in this pipeline run, we're specifying all the runtime parameters, just like our registry, which is the registry where the image will be pushed. So here I'm using the built-in registry for OpenShift, which is a nice thing, because if you're using vanilla Kubernetes, either you have to install an internal registry, or let's say specify some external registry. I'll have to specify a service account, which is at the bottom of the screen, which is another important piece. Because if you didn't have this, you have to create the service account by yourself. You have to attach the RBAC, you have to attach the secret. What OpenShift Pipelines allows you to do is it already gives you the service account, which is called pipeline in this case, which has all the permissions. All right, so now that we have the pipeline run, I specify the image tag, the service account. I'm going to do an OC. So this is showing what OpenShift gives us. OC get service account. So we have the pipeline service account, and I'm going to do OC apply pipeline run. So the pipeline run now is created, and you can see the pipeline has started executing. All right. So we have 3 tasks in total. The first one builds the image from source. The first step just lists all the files in this repository. And the second step, which is step build and push, does the actual heavy lifting of using Canico tool to do the build and push. You have the option of using source to image. You have the option of using Builder. You're free to use whichever tool that fits you. All right, I can use the command line as well to list my pipeline run. I can do a describe as well to see some more details, which will show you the resources, the workspaces, and I can do TKNPR logs as well. So this is going to show the logs. It has some delay, not as fluid as the dashboard, so you'll have to wait a few seconds and all the logs suddenly appear. So I prefer the console view for the logs. All right, so we're waiting for, and that was one reason for me to have this ready beforehand, so that we didn't have to wait for all these steps. So this is the Slack I'm gonna show you. So I have one specific Slack channel configured. So anytime a build and push is completed, you'll see a Slack message appearing here. So the one that you see on the screen, that is not the one. Once, hopefully, if the step finishes, we're gonna see a new Slack message. All right, so we're seeing the build step is going on. It's a Java application, so please be patient. All right, so anytime soon we should be able to see the step build and push. So we're seeing the command line view as well, and so that error is nothing related to Tekton. It's just trying to refresh the logs, and then it kicked off again, and we see the build image from source task is completed. So if that is completed, that means we should have the image on our internal image registry. So we go to image streams and we see we named it Java Tekton. The image is there. Next, now that we have the image, we want a notification on Slack. So we'll switch over to Slack to see if we got a message on Slack. So from the developer side, we can see the pipeline. Task number 2 is completed, which was the sent, and the task 3 is completed as well. So the first thing is we went to Slack, we see the incoming webhook, and yay, the image is pushed, which is a nice message always. And now the application is deployed. We can see that we can just see the running application. Another cool thing with OpenShift is you already have the route. You don't have to configure the ingress. All right, so let's see the running application. It's a very custom application, hello world, but we can do better than that. We can change the name. So hello DevNation. All right, so hello DevNation. So that was the demo, short and sweet demo. But what I'm trying to show you is I'm trying to show you the catalog where all these useful resources exist. So if you go to Tekton CD, the GitHub link for Tekton, which is at the end of this slide, you'll see catalog repository. And within this catalog repository, you're seeing all these tasks. Just the sheer number of tasks give an idea of how much contribution have been put in place. So one of the tasks I reused was right here, sent to webhook Slack. And then it gives you an idea of how to use this Slack. You just install this YAML file, and then you configure the secret, and there you go. And similar to that, I used the Canico tool for doing the build and push. So within task, if I go here in K, there should be Canico. Let me make it slightly bigger. Hopefully that helps. So Canico, but there's also build a task. Right here, so you could use Builder. You could basically pick and choose whichever solution you need for your reusable CICD system. And going back to the presentation now, to get started with Tekton, I added some links. I have the Tekton website, GitHub repo, public Slack channel. So the folks over there are super helpful. If you have any questions, feel free to ask in that question in the channel, and there are experts and even beginners who are very helpful. Finally, we have Red Hat Developer Tekton tutorial link there as well. So this is a super helpful course if you want to have a more structured way of learning Tekton. At the bottom of the last slide, I have linked to my LinkedIn and Twitter. So if you have any question or feedback, I'll very much appreciate getting a knock over there. Thank you so much. I'll stop sharing the screen and open and welcome any questions you might have.
We do have questions. We actually had an interesting chat in the chat with a bunch of folks here. And so I want to make sure we have some questions for you that it could be very interesting. So one from Kamal in particular, he was wanting to know, what if I have things within the OpenShift cluster, things within my Kubernetes cluster, and then I have stuff that's outside my Kubernetes cluster, right? Living in the old world. Does that mean I have to maintain 2 CICD solutions?
So that's a very good question. And I think that's the question that's going in the realm of multi-cluster world. So Tekton being a young solution, I haven't seen much POC or work in terms of multi-cluster management, but one other project, Argo CD, has been very active in the multi-cluster model. So if you have 2 different clusters, I try to understand that what each cluster is doing. If it's from the CI point or the CD point, are you doing CI in one point and just deploying into multiple clusters? Or do you see that differentiation in the question?
Well, I mean, if you let's say you have a big vSphere architecture, right? Like old
Right.
school vSphere and it's completely not Kubernetes. And for that, you might have built out a big Jenkins CICD solution
Correct.
versus, let's say, what's now Kubernetes-native in Tekton.
Yeah.
Do you actually see people using Tekton to go back to the old world, if you will, and try to instrument and manage all those older things?
Right. And that's something a lot of existing enterprise clients have the same question. And it's going back to what I was mentioning, that in order to truly leverage Tekton and Kubernetes, you probably would consider restructuring your application that runs on containers and on Kubernetes. Because if you really have a monolith which is not even on Kubernetes, thinking of Tekton and Kubernetes native solution might not be the right approach, because you're going to be stuck somewhere or not. Because at the end, people are going to ask you, what are your containers? What is your log? And it's just not going to sync very well, in my opinion.
Yeah, I think there's some gotchas there when it comes to dealing with older infrastructure versus new infrastructure. This is definitely Tekton for new infrastructure, if you will. And there's a question related to that too, from someone who has OpenShift 3 today, basically who has OpenShift 3 was all about Jenkins, and Jenkins was our native pipeline solution. And OpenShift 4, we've deprecated Jenkins. So Jenkins still works, but we've deprecated Jenkins, and we want people to move to Tekton. And so, how to migrate? Have you looked at any kind of migration strategies, or do you have any thoughts on, how to move from the Jenkins world into the Tekton world?
Right. And that's another very solid question, because I haven't used Jenkins on OpenShift 4 3.11, so I can't exactly comment on that piece. But I have actually worked on migrating Travis-based build system from Tekton in one of my older teams. And the experience I had was, there were two avenues. One was whichever Groovy file or Groovy script or the Jenkins or Travis script you have, you check everything and then transition into Tekton, which seemed very challenging and very hard. The second way was much easier. The second way was, the first scripts, they were doing something. They were probably fetching some cloning a repo and doing a build and push and some security stuff. So do the high level abstraction and start doing all those in the Tekton world from scratch as a greenfield. So take the behavior driven approach and then redo from scratch in the Tekton world, which in my experience, like we did that from Travis to Tekton. That was much smoother than trying to change all those scripts to fit into a YAML.
Yeah. I like what you just said there, by the way, because thinking through it, taking that Groovy file, the Jenkins file Groovy script, and trying to just port it over doesn't make any sense at all. It's just a different world, right? Now, do you happen to remember, there actually is a Tekton task catalog on the internet someplace, but I can't find it anymore, only because we've not really popularized it much. But do you remember
Tekton
the URL for it?
Test, do you mean the test for the Tekton repository itself?
No, there's actually a nice website for Tekton tasks. Because one question
Tekton tasks.
Yeah,
Tekton tasks, you mean the reusable tasks?
Yeah.
I think that's the one I was showing, right, under catalog, or you're mentioning something different.
I don't know. Now, show me that catalog again.
Yeah. Let me, because from what I understand, even can you see this task?
Okay. All right. So there is actually a website that makes it pretty, but I just don't know where that is. So this is
okay.
But this is good. Actually, give me the link if you would, into the chat.
Yeah.
And the reason I say that is because Kamal is asking, well, what are the integrations? What are the tools? What can I do with this thing? And so the beauty of Jenkins is because you got a plugin for everything, right? And so this is kind of the equivalent of that in the world of Tekton.
Yeah, no, absolutely. And even when I was at IBM, so what they did was they forked this repo and then they customized some of the tasks to fit IBM cloud specific tasks. So that's something I see many vendors doing it, that they fork the main Tekton catalog task, and they just repurpose for their organization. Let's say a team of 10 can do that, and then thousands of employees in that company can just use those Tekton tasks that is customized for their company and their needs.
Okay. Now, Alex here, Alex Caesar or Alex Cesar. It's an interesting name. I don't know if it's one name or two names, but he asked an interesting question. So he's going to run an integration test. And so that's a common step within your pipeline, right? To run an integration
Correct.
test. But I get the perception he wants to fan out, because he basically says we got to run 16 parallel integration tests.
Mm-hmm.
So, and we want a thread and a database instance per. Okay. So and they use Docker Compose today with Gradle to basically support this solution. So, running the Docker daemon itself in the context of Jenkins was always a little bit tricky. Running it in the context of Tekton is a no-no, right? Running the Docker daemon in Kubernetes is a no-no. Can you think of a way to do that fan out, run 16 simultaneous integration tests, all with their own database, and then, of course, get the results from all those and aggregate them back?
Right. So this is a very in-depth question. So what I'll do is I'll try to break it down into smaller, chewable pieces. So the first thing to do with the persistence. So when we think about the persistence, that is exclusive, that is not specific to Tekton per se. So if you think of any solution that is running on Kubernetes, that could have persistent PVC, PV, whichever. So I'm not going to focus on that one because that has nothing to do with Tekton. I'm going to focus on the fan out part. So the fan out part is you have mainly two approaches. One app, actually, there could be more, but two comes to my mind. One is you have a pipeline and you have, let's say, 16 tasks. Now, all these 16 tasks could go in parallel because remember, they could run on any nodes, and you can even specify the resources, even like how much memory or bandwidth that you want to assign to each of them. Or you could have multiple pipelines. Let's say you can have 4 pipelines with 4 tasks each. And that's something that your architects have to kind of dig deeper and then find out which one makes more sense. Because if all the tasks are passed, then the pipeline will pass and the pipeline run will pass. But if you have mutually exclusive tasks, so let's say you have some notification tasks that, okay, what if all my observability fails or my notification fails? That's not a big deal. That's the architectural decision you have to make, whether to put all the tasks in one pipeline versus dividing into multiple pipelines. But the fan out feature is already there because this task could run as a graph.
Yeah, because one nice thing about the Tekton architecture, everything runs as a pod. So all these tasks are running as pods, steps in the steps are basically containers in a pod. So I don't see I think you have to reimagine this concept of running 16 things in parallel that all connect to their own database. But those would run as pods all on your different worker nodes, right? So if you have 16 worker nodes, you could scatter them across the 16 worker nodes even.
Correct. And then your Kubernetes, the OpenShift or Kubernetes cluster, that also matters, that what is the configuration you're putting, what's the storage limit, how quickly the logs will fill up, because with 16 different tasks, the logs will be filled. So all these tiny details, I think the nice approach would be if you have one POC, so a small POC, to do that first and see what are the hiccups, and then go from there rather than trying to do actual production level work in the first go.
Yeah, and that's a good point too about the PVC, right? The concept of the workspace in Tekton is basically all it is a PVC. And so your actual network distributed storage might be a bottleneck, and you would want to make sure that's whole and ready to run and correctly mounted. Another question though about the reusable task, and from that catalog we just mentioned. In that case, are you copying and pasting from the catalog into your local environment, or can you set it up so you inherit from the catalog should the upstream catalog change?
So I haven't seen major changes in the catalog recently. So one change would be when Tekton goes from, let's say, alpha to beta, you might see some changes. Most folks, I've seen that if there is no change, for example, the tasks requires 3 parameters. Let's say it needs your GitHub URL, the revision, and the image tag. You can just pass it from your pipeline run. You could use it directly. I've seen even context where, remember the send to webhooks, the raw GitHub user content, in the actual link. So that should be fine and it wouldn't break. But if you want, you could have a webhook running that it always checks whatever the latest, and then you have a local Tekton repo. So the local Tekton repo is updating from the parent repo. But no team is 100% automated. That means you don't even check typically people like goes to that if you're active. If you're investing on Tekton, probably some folks on your team are joining those contributor calls, the Tekton Slack, and any major changes on those tasks will be discussed, and you can take actions then.
Yeah, because one thing, for instance, Maven as the build tool, right? That could get updated, and then you would like to be on the latest version of the Maven for that task, or the
Correct.
Git client, right? Any of those kinds of binaries could get updated for various reasons, and you'd like to be on that latest version. Yeah.
And one other point there is most of the time the backward compatibility is true. That means even if it's updated, let's say from 4.5 to 4.6, oftentimes it doesn't break the previous thing. And even if it breaks, we are at a point in the industry where we want things to break because we are not scared of things breaking. Because what if it breaks? We're not treating it like pet, like cattle. It breaks, fine. I understand that the task is the issue. I go ahead and update it. That's okay.
Yeah. And so there was actually one question from DJ Maddie there. We're talking a little bit about how to get an OpenShift cluster. And he was basically saying, well, the OpenShift.com/try option, which is free, but it is 60 days, right? But I've never run a cluster for longer than 60 days. I've actually never run a cluster for longer than 10 days because normally I recycle them way too often. The whole cluster is cattle to me, right?
Yes.
Yeah, everything is cattle now. There are no more pets in this world. Well, at this point, I think we are out of time. I thank you so much for the questions and the answers because I think that was a lot of fun. We had a lot of discussion in the chat. Zafar, thank you for the compliment on the new haircut. I'm going with shorter hair now, post-pandemic. I'm trying to get out of my pandemic long hair, going with short hair now. And yeah, all right. So thank you, Alex. Fantastic. And yes, the Tekton, by the way, just so for people know, is fairly new. Okay. So I'm not going to sugarcoat that. It is fairly new stuff. It is moving very fast. It's maturing very quickly. It's not nearly as mature as the Jenkins ecosystem by any stretch of the imagination. However, it is Kubernetes native. It takes advantage of Kubernetes native architecture as the scheduler. There is no Jenkins master here because that's Kubernetes itself. And so that is the massive win, the big benefit. So definitely start checking it out. But I do recognize it'll be a slower experience as people ramp up.
There is no hundreds of plugins as well.
Yeah, exactly. Well, Dewan, thank you so much for that. And I thank you all today for hanging out with us. We saw a couple people on Twitch. We had a lot of people on the YouTube channel. Well over 100 people today on the YouTube live stream right at this moment. So that's absolutely fantastic news. But at this point,
it's a pleasure to be here.
Yeah. Thank you. And so at this point, we do need to bid everyone adieu and turn off these systems and let everyone go have a nice day. Do look forward to more emails from us around future DevNation events. Don't forget, we have the Tuesday show with Sebastian Sebi, who's been on our chat today. He did some crazy stuff with Doom, Space Invaders. Let me see. He also had some Minecraft in there too. So, he's getting crazy. Maybe we should challenge him a little bit more and see if we can actually get some Fortnite going. Because, Fortnite runs on Kubernetes as an example. We can definitely have some fun in that category. But I thank you all for your time. And at this point, we're going to be out of here. Thank you.